Welcome to part 2 of 3, Compression Spring Design, a PlanetSpring.com production. In this video, we'll see how to calculate the necessary force needed at our preload L1 and working heights L2, number 2 in our 5 key objectives, demonstrations of L1 and L2, how to measure L1 and L2 yourself, and how to determine the correct spring material for your application. Key objective number 2, calculate how much force we need at our loaded and working heights. The load of a spring is how much force and weight needed to move a spring a particular distance. For example, you have a 10-inch long spring and a rate of 10 pounds per inch. You want to know what the load is if you need to travel 3 inches. So you need to take the rate, 10 pounds per inch, and multiply it by the distance you're traveling, 3 inches. This will give you a total load of 30 pounds. The formula to determine load is rate times distance traveled equals load. In our example, the load would equal load equals 10 pounds times 1 inch, therefore our load equals 10 pounds. Definition of L1. L1 equals preloaded height. You need to determine your preloaded height, which will always be less than your free length, as the diagram showing. Determining L1 preloaded height. Let's assume your spring's preloaded height is 2.5 inches. This means your spring will be preloaded half an inch of distance. Next, you need to determine how much force you require at this 2.5 inch height. The way to determine how much force you require at L1 and L2 is simple. You simply measure the weight of force at each L1 and L2 height with a force gauge. You can also weigh the two parts of your product or device on a digital scale or load cell. This will give you a fair assessment of the required force needed to do the job at L1 and L2 heights. Determining L1 preloaded height. After measuring the force, you determine that you need 5 pounds of preload force to move half an inch. So now you know your L1 is 5 pounds at 2.5 inch preloaded height. Determining L2 working height or fully traveled height. Let's assume your spring's working height is 2 inches, meaning your spring will travel a distance of 1 inch. Next, you need to determine how much force you require at this 2-inch height. Again, you weigh the two parts of your product or device on a digital scale or load cell, where you can measure the weight of force at each L1 and L2 height with a force gauge. After weighing your device, you determine that you need 10 pounds of force at 1 inch of travel. So now you know your L2 is 10 pounds at 2 inches of fully traveled height. To check that your calculations are correct, use a load tester to double check your work. Key objective number 3, determine the correct spring constant or spring rate needed. The rate of your spring is a constant. This constant will let you know how much weight is needed to move the spring 1 inch of distance, or in the case of metric measurements, 1 millimeter of distance. As we figured out with our calculation of L2, the amount of force needed to travel 1 inch is 10 pounds. Please remember compression springs are linear, which means if your compression spring has a rate of 10 pounds per inch, it will take you 20 pounds to move 2 inches of distance. Let's recap. Your L1 is 5 pounds at 2.5 inch loaded height. Your L2 is 10 pounds at 2 inches working height or fully traveled height. So naturally your spring constant or spring rate needs to be 10 pounds. Why? Because the spring constant or spring rate is equal to the amount of force needed to move the spring 1 inch of distance. If you need more help designing your spring, you can use the compression spring calculator on PlanetSpring.com. Key objective number 4, determine the correct spring material for your compression spring design. Will your spring be used in water or in high temperature environments? There are many kinds of spring materials that you could use for different kinds of environments. For example, 302 stainless steel is great for fresh water, whereas Inconel X750 is great for 1,000-degree working temperature. For a complete list of properties of common spring materials, please visit PlanetSpring.com. Please continue to part 3, and you will learn how to measure active coils, OD/ID free length and wire diameter, a sample calculation with incorrect variables, a tutorial on how to fix the problems in the first design, and a finished design achieving all 5 key objectives.